Welcome to part 2 of this video about why we use arrays, loops, and objects. For a quick recap of the first part of this video, we took a very simple program that printed out a report about two kinds of fast foods that I liked, and we modified it so that it could accommodate many more pieces of data. So in short, our modification used arrays and loops, actually one array and one loop, so that it could store more types of foods, but yet the code for printing out the report will always stay the same. That's really the important thing to see here, is that this loop can print out as many foods as you have kept track of in your program. If you notice, there's nothing in here. There's no actual number that tells you how big your database of foods is. Instead, it's got a variable I, and that variable I is set up here. So if it says 5 and you have 5 pieces of data, this thing's going to print out 5 things. If you have 20 pieces of data, and this thing would be set to 20, this thing would print out 20 things. It would look exactly the same. It would say food sub I here. This would be I plus 1. The loop would be going from I to just under the total foods. But so the code would look exactly the same, but it would print out as many items as you have available. And that's important because many problems that we solve in computer science don't just have 5 pieces of data. They may have hundreds of pieces of data or even more. And so you need to write code that can accommodate that kind of scale of information. Okay, so that's just a quick recap of what we did in the last video. If that makes you think about that last video in a different light, I suggest you take a look at the video again and watch it over, if that's not what you got out of it, especially. So the question now that we are on to is, why would we change a program like this to use objects? So what about a solution to a problem lends it to using objects? So that's a really good question. Right now, what this program does is pretty limited. So it's only storing a very limited type of information about these fast foods. For instance, it's just a string. So this is for each of these 5 things, all we know is the name: Five Guys cheeseburger, Wendy's baked potato, White Castle slider, Wendy's frosty, and Hardee's monster biscuit. Okay, so what if it was important to store the information, first of all, differently, a little bit differently, and what if we wanted to store additional information? So what do I mean by that? Well, I like that this shows the item, but what if I really wanted to see the type of item that these things were? Like I want to see that it's a cheeseburger, a baked potato, a slider, a frosty, and a biscuit, or a monster biscuit. Okay, but it still is important to keep track of the place that it came from. So I don't want to lose that, but I really want to highlight. So I want to see these two pieces of information as separate in each of these descriptions. Right now they're stuck together. I'd like to separate them because I'd like to say something like, maybe I'd like to say, I'm in the mood for a cheeseburger. Well, where should I go for a cheeseburger, for example? Well, apparently my favorite cheeseburger is from Five Guys. So that's something that might be useful if you separated these. So instead of looking for Five Guys cheeseburger, you'd know that you're looking in your database for a cheeseburger, and you can tell that it's from Five Guys. Something else you might want to do is, with a database like this, maybe you've got a list of your favorite foods from different fast food restaurants, and you want to keep track of how often you eat them, because that might actually then change your perception about which ones are your favorite. You notice that you're eating one more often. Maybe you want to change it in the list, or maybe you realize that you almost never eat one, so maybe it isn't your favorite. In any case, maybe that's something you'd want to keep track of, and you could actually keep track of that. You could only keep track of it if you had some way of communicating with the program. So we'll need to modify this program to somehow accommodate the data differently, and also to interact with the user to keep track of some additional information, which is in the number of times you've eaten something. Okay, so first of all, let's think of how that changes the data that we're storing about these fast foods. Right now we just have a string. If we want to keep track of the cheeseburger separate from Five Guys, then we would need two strings, two separate strings. We'd need a string that says Five Guys and a string that says cheeseburger. Okay. And if we wanted to keep track of how many times we've eaten a Five Guys cheeseburger, we would need an additional piece of information, which is, I would say, probably an int. So an integer keeping track of the number of times you ate one of those items. So we have three pieces of information now that we want to store, and I guess we could store it, all those things, in separate variables, or we could have separate arrays, but you can see that we could already see that there's some benefit to storing information in an orderly way, like in this list, so that we can access it very easily. Wouldn't it be nice if we had an orderly way to group the information of Five Guys and cheeseburger and the number of times we've eaten it? So the way that we should do that is by having an object that contains all three of those pieces of information. And in fact, we also need some functionality. So we need to be able to change the number of times we've eaten something. Because if we go and eat two Five Guys cheeseburgers, we want to increase the count of times we've eaten a Five Guys cheeseburger. So not only do we need to keep track of information, we also need to be able to change that information. Okay, so that sounds like a job for objects, and in order to have objects in our program that keep track of things, we need to create a class that tells us what the structure of the object is and what kind of functionality that object will have. So we need to create a new class in this program. Okay, let's call that class, I'm just going to call it snack. I guess I could call it food, but I feel like calling it snack. Okay, so this is how you create a new class in Java. You've seen this before. We give it a name. I'm going to make it public, and I'm not going to give it a main because it's not its own program. It's just an individual object that we'll be using, but it is going to have constructors, and I guess I'll tell it to generate comments. What the heck. I won't be focusing too much on comments in this video because I'm trying to be focused on creating a video that just highlights the concepts that we're talking about. Okay, so actually I'll just remove the comments to streamline this video. We don't have all day. Okay, so right now we've got the bare skeleton of a class here. Don't worry about this package declaration. I've created a package for this project, and we haven't really talked about packages, so let's just ignore that for now because it's not really important for what we're doing. So we've got a public class snack that we created, and it's got a constructor called snack. The constructor is what gets called when you create a new one of these, a new object from this class using the new keyword. And we'll see that later when we create a new one of these. All right, so what does snack need? So each snack has three pieces of data that we've already identified. We have one string, another string, and then an int that we talked about. Okay, and we're going to make these private. So they're going to belong to this class. By making them private, it means that only this class will be able to access them directly. We will be able to govern how these things change or whether they can change at all. Okay, so our first string was the name of the food, so let's just call it, I'm going to use the convention, I'm going to call it mname. Okay, so we have a string that's the name, and I'm going to call the other thing we had, so that was like cheeseburger, so the name of the food is cheeseburger. Well, actually, let's call that type. Forget name. We're going to call it type. So a type of a food, and I'm using m for member here. We talk about these as member variables, as attributes or fields. So this is a convention that I like to use. So we've got type, and we'll say vendor, because basically who sells it. And then we also wanted to keep track of number of times we've eaten it. So let's just call that m times eaten, or something like that. So basically it's the times eaten. And we're going to start out with that as 0. Okay, we will initialize it. Not only do we declare it, but we're going to initialize this. We don't know what to initialize type or vendor to, so we're going to leave that as is. Okay, so here's our constructor. So I want to think about this for a second. When we create the snack, so when we make a new snack, what do we know about that snack right when we create it? Well, we should know, when we create it, we should know the type of snack it is and the vendor it's coming from. Okay, we won't necessarily know the times that we've eaten it, because of course that's going to change over time anyway, so we want to deal with the times eaten separately. So think about, if you think about creating the snack, think about giving the information that we need to create the snack at the same time that we create it. So what we're going to need is to change the header of the constructor so that when we call new snack, we can send in the information, send in 2 strings that are used for the type and the vendor. So we could put the vendor first, since it seems to come first in all the descriptions we have. So the vendor, like 5 guys, and the type, like cheeseburger. So let's say we have a string that we're sending in, and locally we're going to call it vendor. This name is only used inside of the constructor. The name of this argument that is being passed in to the constructor. We need a second string sent in that is the type, so we'll just call it type. And again, these names that appear inside of the argument list of the header of the constructor are only used inside of the constructor's method itself. Okay, so now that we've got the vendor, so now we can imagine that when this function is called, when this constructor is called with the new keyword, the vendor and type strings will be sent in through these parameters. So we will have a vendor and we will have a type. So when we're writing this constructor, we have to kind of imagine or pretend that we have the vendor and that we have the type. So once we have the vendor and type, what do we want to do with them? We want to hang on to them in our member variables that belong to this class. So we want to, for example, we want to set the type to the type that was sent in. It's as simple as that. We assign, once this is called, the type, which is sent in through here, is going to be assigned into our variable. Why is it important to do that? If it's being sent in and this name is being used, why don't we already have it? Why do we have to set it to the member variable? Well, the reason that we have to do that is because when we call this constructor, eventually this constructor call is going to end, and the program will go on running. Well, these variables that are arguments of a method only exist for the short time that this method is running. So once the method is done running, once it's finished the creation of the object from the class, that data will be lost unless we save it in some more semi-permanent form. And as long as this the object from this class exists, then this member variable will exist. So we'll store it there, since it exists for the whole life of the object we create for this snack. We're going to do the same thing for vendor. We're going to store the information that was sent in our member variable. And that's it. That's all our constructor is going to do. So once this constructor is called, if you look at this small piece of code here, what it says is we have a class snack that's going to create objects. We're going to use it to create objects, and those objects will each have a type and a vendor that will be stored as strings, and it's going to keep track of times eaten but the times eaten will start out as 0. And when we call the constructor, we have to send in the type and the vendor, and they will be stored. And so once this is called, the type and the vendor will be stored, and we'll have times eaten will be set to 0, and that will be our object. So right now you can't do anything with this, with the objects that are created from this class, except you create them. You can just create them, and then there's really nothing else you can do, because you don't have access to any of this data because it's all private. So you can just create objects. So we want to be able to do things with this object. What do we want to be able to do? Well, we want to be able to if we've got a hold of this object, we want to see what's the type and what's the vendor. So we want access to those strings. We could make these public, okay? But if we made this data public, other classes, other objects would be able to change that data. We only want people to be able to see the data. So instead of making the member variables public, we're going to create a public method that returns a string when it's called. And we call this an accessor function because it allows us to access the data that's already in the object. So we're going to call this public string get type because we want a method that allows us to get the type. And because we don't need to say, there's only one type variable, we don't need to send any information to get the type. We just want that information to be sent back. How do we send the type information back? We send it back by returning type. Okay? So that's an accessor for the type. It's public, which means that other people can call it. It returns a string. It's called getType so that people know what they're getting when they call it. And it returns the type variable. Okay? Now I'm going to copy and paste because we need a second accessor for vendor. And it's going to look exactly like that. So get vendor. And in this one, we're going to return the vendor. So now, what do we have now? We've got a class that can, that when it's created, it stores the vendor and the type, and it sets the times eaten to 0. And you're allowed to get the type now and get the vendor. So you can actually do something with this class now. Okay? All right, so things are getting a little interesting. We also want to be able to get the times eaten. So how will that accessor look differently from the accessors that we've created here? If you want to pause the video and think about it, feel free. Well, it's still going to be public because we want other people to be able to call it. Okay, but it's not going to return a string, is it? Because times eaten is not a string. Times eaten is an int. So it will return an int. And we have to think of what to name it. Why not get times eaten? So it's clear. This also doesn't need any arguments. No parameters are necessary for this. Unlike the constructor, we're not sending anything into any of these. But again, this is a very simple method because it just returns times eaten. All right. Now, we talked about one other thing that needs to happen in this object. So a change that we're going to need to make in this class that this thing doesn't do yet. Can you think of what that is? Well, we talked about keeping track of the times eaten. Right now, it's set to 0 and it never changes. It's okay that the vendor and the type never change because that's basically the kernel of information that makes this object relevant. So once we've created it, there's no reason to change it. We can always, if we want to keep track of a different type of cheeseburger, for example, we can always make another cheeseburger object. We don't want to change this one. But how do we change the times eaten? Well, we could let people, so one way, so we've got accessors, we can create a mutator. So we could say, so a public mutator, and this mutator wouldn't return anything. It would instead, it would allow you to change. So since it doesn't return anything, that would be void. And we would call this something like set times eaten, because it would allow you to set the times that you'd eaten a cheeseburger. Okay, so we could complete this function allowing you to set times eaten, which would make a nice balance with the get function. So set would allow you to set it. So if it was 0, you could set it to 2, you could set it to 5, you could set it to 10, you could set it to 3, and then you could also get it when you wanted to get it. However, I've got an idea for this program. Instead of setting the times eaten, if this object is just meant to keep track of the times you've eaten this cheeseburger or whatever it is, then let's just let the people who use it, let's only let them add to the times eaten. Why? Well, we want it to always go up. So, or that's my idea anyway, for the purposes of this program. Let's only have it increase. In other words, if you come home and you've eaten 2 Five Guys cheeseburgers, then you'd run this program, you'd add 2 to the number of times you'd eaten the cheeseburger, and it would go up by 2. So you wouldn't have to know the previous amount of times that you'd eaten the cheeseburger. No matter what it was, you'd add 2 to it, and it would increase. Okay, so so this is a kind of mutator as well. This mutator doesn't allow you to directly set the data. It only allows you to add to it. Why is that important? Well, I just thought it would be an interesting example to show that when you make the data private and you create the accessors and mutators, that you get to say how that data can change. So you have some control over how that data changes. When you create this class, the users of this class then have to interact with the class the way that you decided it should be. All right, so when we add to the times eaten, what kind of data are we adding? Well, we're adding an integer. So you've eaten a hamburger twice or 5 times. I guess you could talk about fractional values of eating a hamburger, but we are not going to do that. Okay, so int, let's see, I guess times. So, or new, let's call it new times. So new times is we send in an integer. We're going to call it new times. So so now how does our member data change? How do our fields or our attributes change when this add times eaten method is called and new times is sent in? Can you think of the code that goes in this routine? Well, of course, what we need to do is we need to add the new times to the existing times eaten, which looks like this: m times eaten equals the previous value of times eaten plus new times. As we've said before, this works because this, of course, doesn't make sense in math class because the equals is a balance, but in the case of a programming language, the equals sign is an assignment statement, so we most properly can read it from right to left here. We can say, look at the right side, m times eaten plus new times, that's evaluated, becomes some value, and that value then is assigned into m times eaten. Okay, so now there we've got an object, or we've got a class that will create objects that keep track of type and vendor of the food of one single snack that we like, and also the times that we've eaten it. So here I've created a UML class diagram to allow you to see for a class that we're familiar with because we just created it, what would a UML class diagram look like for this class. Here's one version of what a UML class diagram might look like. So we have our class called snack. It's got a little icon here that indicates that it's a class, and we've got the name of the class called snack. And as you're familiar with from our discussions in class, these diagrams have three parts to them, and the first part has the name in it. The second part contains the fields or the member variables, and the last part, the bottom part here, has the methods. And so let's take a quick look at what we've got there. So we've got three pieces of data, and you can see, if you can see this hopefully in high definition, you can see that we've got two strings, and we've shown their names here in this diagram, and we've got an int as well, and we've got the name of that. These are members of the class snack, member variables. And this little red square here indicates that this data is all private. And it's private data, meaning that we cannot directly access it. Okay? Well, so how do we access the data? Well, we can access the data, we can see and modify the data by using any of these methods here. So we can create, here are the things that we can do with it. We've got a constructor. By the way, these little symbols here mean that these are all public methods, which means that other classes that you're creating can access these methods. So we've got the constructor for this snack, and it takes two strings, okay, which are shown here. We've got the ability to get the type, get the vendor, to get the times eaten as an integer, as an int, and to add to the times eaten. And you can see here that add times eaten returns nothing because void means returns nothing, but it takes an int. Okay. So we've created a whole class to store some data that we'd like to store, all in order to make changes to our program to make it a little bit more useful. So I'm going to make some changes to this program. I'm going to pause the video, make some changes to this program, and then talk about the changes that I've made instead of typing it all out for you. Okay, I've made some changes to this program now. You should notice that the total foods hasn't changed. I haven't changed the amount of food that we're keeping track of here yet. But what has changed is that instead of having an array of strings, I've got an array of snack, an array of snacks. Okay, so snack array, called foods, still got the same name, equals new snack, and the size of the array, new snack array, size total foods, so size 5 in this case. Now when I create the snacks for the array, I have to make a new object of this class type each time. So I have to make each snack that goes into each space in the array. So food 0 equals new snack. Notice that I'm making use of that constructor. It's the only way I can actually set the type and the vendor. So I make a new snack, Five Guys cheeseburger. I'm calling that constructor over and over again. Each of these times I call the constructor, okay, for each one. And here's my loop in which I'm printing out each food. Okay, so here's the sentence it says. Remember from the last time we output this, we get a number, we print out the food, and let me add an extra bit here. So I'm going to add a period and then something like I've eaten it, I've eaten this, and then a space, and then I'm going to say foods I dot get times eaten. Okay, and then plus another space times So it'll just say how many times I've eaten it when we make this easier so it fits on the screen. Okay. So I've eaten this many times. Okay. And so our report now will show a little bit about the additional functionality that we have in this. Actually, because right now it's going to default all those to 0, I'm just going to put a single call in here bumping one of these foods up. So I'm going to say, well, I haven't had any of these in a long time, so I really haven't kept track of how much I've eaten them, but I do know that I had a Wendy's Frosty the other day, so I'm going to say foods 3, and I'm going to call foods 3, which is the third is the fourth food in the food array in our array of snacks. And I'm going to call add times eaten. And I'm going to say, well, I had 2 Frosties last week, so I'm going to add 2 to that. Okay? And then, oh yeah, that's right, I had another Frosty this week, so I'm also going to add 1 to it. So we should have eaten 3 Frosties, and that should show up in our output. All right, well, let's generate the output and see what we get. Okay, we got to save. Okay, what happened here? It's kind of interesting, actually. We've got 1, 2, 3, 4, 5 snacks. Okay. And it looks like it did keep track and add up 3 times for the thing that was 4th on the list. However, it doesn't show the name of the vendor. Why? What's it doing here? Well, when I created the output string, I told it to concatenate the 1, or let's see, yeah, well, 1 dot, in the case of the first line, it's I plus 1 dot with a space, and then I didn't pull out the data. I didn't use the accessors at all. So I could have said, for instance, I could say food sub I dot get name, get type, or get vendor, but I didn't do that. Instead, I put foods dot sub I in there as if it was a primitive. Well, what happens when you do that? Well, actually, what happens is it calls the object's ToString function. Every object actually has a ToString function. It's part of every class, except you don't see it. Okay, you can override it, but you don't see it. If you haven't overridden it, what you get is you get this information of the package that the object is a part of, that its class is a part of. You get the class name, and then you get it like a unique ID that identifies the object. Not very useful. It's not ever useful to output this, except maybe if you're debugging, I suppose. But that's what you're going to see if you just try to put this, if you try to put an object in a string and concatenate it into a string, and treat it like a primitive, like an int or another string object, for example. So we've got to fix that. One way to fix it would be to say something like, instead of food sub I, we could say food sub I get type. Okay, that's one thing we could do. So it's a call, method call, so we're not sending anything in, but this will return the type. And now if we run the program, and this is kind of nice because what we see now is we don't see the vendors. We just see the type of food it was. So this is something we didn't have the ability to do before. We see that cheeseburger, I've eaten this 0 times, baked potato, slider, Frosty, eaten that 3 times, and monster biscuit, I've eaten that 3 times. We couldn't separate out those things before. Okay. So here's another way that we could do this. So what I've done now is I've switched back to snack.java and I've added a new method called ToString. This is overriding the object's ToString method, and you can see what it's returning now. It's returning, instead of it returning that that information about the object and its unique identifier, which is not useful to the user, it's returning a new string that's concatenation of the vendor plus a space plus the type. And we can see what the result of that change is for the UML diagram, you can see that it's got an additional method, I should say, in it, ToString, that returns a string. Okay, and if we go back to food tracker and we change this code back to just returning foods sub I, we will get the ToString functionality to work. Let's run this and see what, let's save it and run it and see what happens. And look at that. So what it's doing is it's calling the ToString function. We don't even see that call. It's hidden. It's kind of a sneaky way of doing this. But every object has this ability. And it's returning the string that's the vendor and the type. And it's saying I've eaten it 0 times, 0 times, 0 times, 3 times. And that's how that works. I'm not going to make this change to this program right now, but one change that that you can think about making to this program is having a way for the user to actually continue to add to this list. Perhaps you could list out the catalog of items, and you could have someone enter a number, and then to select an item, and then maybe they could tell you how many more times they've eaten that item, so that it keeps track, so that the database continues to keep track of all of your eating of fast foods. However, if we did that and then we quit the program, we would lose all that data that we'd held on to. So that's another thing to think about, is how could we possibly use this same kind of program and make it a little bit more useful by having it store the data in some way that is more persistent. And that's a subject for yet another video.